Welcome. Let's solve a system of equations that has three variables in it. Our goal here will be to put into coordinate point form an x and a y and a z. When we use all three of them, it's a three-dimensional system, but it's still a point for three planes. Thus, we do have to put it in coordinate point form. So if a test question like this was similar, and somebody put the answer as x equal to whatever number and y equals to whatever number and z equals to whatever number, they would definitely lose some credit for that. Now let's take a look at these three equations and recognize that we're going to do the elimination system and then later substitute as well. But we'll start by either eliminating all the x's or a couple of x's so that we can get down to a yz set of equations, or we would eliminate the y's and have two xz equations, or we would eliminate the z's and have two xy equations. So the issue here right now is to determine which one is better to do. And there's really no right or wrong to that. You can choose to get rid of the x's or the y's or the z's depending upon what numbers you want to work with. Well, I'm going to choose to work with the x's. So what I'm going to do is I notice this 6 and that I could take the -2 and multiply it by 3 and I would get a -6, and the -6 and 6x would cancel. So I'm going to write 6x plus 8y minus 5z equals 14. And underneath it, -2x plus 5y plus 3z. Let's write that z a little bit, or that 3 a little bit better. 3z is equal to -25. So this one I'm going to multiply by the number 3. So the first one's basically going to stay the same, 6x plus 8y minus 5z equals 14. The second one becomes -6x plus 15y plus 9z equals -75. And now I am going to add these, because if I add them, those go away. And here I get 23y plus 4z is equal to a -61. Let's make all of this a little neater. So that gives us one of the two equations that we will need. The next thing we'll do is we'll get another one. So we'll look back at these x's and this time do something a little different. We will turn the -2x into a -4x. So I'm going to put the -4x, I want to do this in the blue, -4x minus 3y minus 8z equals -39. And underneath it, the -2x plus 5y plus 3z equals -25. And this one I'll multiply by 2. I could choose to do -2, so I get a +4 for it, and then I could just add. But I want to do at least one of these where I show that it's going to be a subtraction one, and go over to make sure everyone's comfortable, anyone watching is comfortable with how to do that. -3y minus 8z equals -39. So this one did not change. This other one does change. So I get -2 times -2 gives me a -4x. And then I get plus 10y. And then 2 times 3 is I get a plus 6z is equal to -50. And now here, what I'm going to do is subtract these. So I'm going to subtract. And so that means a double negative here, -4x plus a 4x. So that means these cancel out. Negative 3 minus 10 gives me a negative 13y. And then we get minus 14z is equal to 11. So here we have the two equations that we need to solve for one of those variables. So that will be the third step to do. I'm going to write those down and then analyze them, looking at them together to see what I want to do with them. So now I want to see, I could multiply the top one by 13 and the bottom one by 23 and get rid of the y's. Or I can use these two and multiply by 14 and 4, or I can use a lower common multiple. For instance, I could use 7 and 2, and I'll get 28. So that will be easier ones to use. So I think that's what I'm going to do here. So I'm going to rewrite both of them. And the first one multiplied by 7 gives me 161y plus 28z equals negative 427. And the second one gives me negative 26y minus 28z. So you see where we're going with the z's. It's 22. So we can add these. So this one, the y's become 135y. These cancel to make 0 equals negative 405. And now I can divide both sides by 135, and I get that y is equal to a negative 3. That gives me one of the three numbers here, a negative 3. And we can now use that for the fourth thing that we'll do. I'm going to take one of these equations, and I'll use just because it's there and a little smaller numbers, I'll do negative 13 times negative 3 minus 14z equals 11, and I'll solve for that. We get positive 39 here, so that means I'll subtract 39 from both sides. Negative 14z is equal to a negative 28, divide by negative 14, and z is equal to 2. That's the second of these. So that one I'll put also in the black here. And up top, we'll put a 2 in for the z. And now for 5, the fifth step is we will basically do that again with one of these originals. It can be any one of them. I think what I'm going to do is choose the bottom one just because I could have chosen any one of them. I have 6x plus 8y minus 5z is equal to 14. Let me confirm that. 8y minus 5z equals 14. All right. So the 6x is here. That's going to be 8 times negative 3, replacing the y, minus 5 times 2, replacing the z, is equal to the 14. So I have 6x minus, 24, minus 10, so minus 34. Okay. 24 minus 10. So 6x minus 34 is equal to 14. Okay. Going to add 6x equals, let's see, did I get my negatives right here? Okay, plus 34. And so I get 48. Let's divide by 6, and we get that x is equal to 8. I can do it this way. So now we come back up here, and we would put the 8 in here. And I'm also going to do it down here where I have all of them anyway, is that we'll do the 8, the negative 3, and the 2. Now, remember something. If you were to answer it this way, x equals 8, y equals -3, z equals 2, you will lose points unless answered in this format. Okay, I think that's pretty clear. So please make sure you answer with the parentheses, -2, put the 2 parentheses and the points, the x, y's in between them. Let's take a look at another problem, and we're basically going to do the same exact thing. It just comes down to which of the variables do we want to get rid of. Okay, and it can be any one of them. In fact, I will not choose x in this case on purpose. So we're going to identify first which variable to eliminate. And I'll actually put that as really the first thing to do. First thing to decide which variable to eliminate. So in this case, I'm going to choose to eliminate the y's. I could choose any one of them, but I at least have a negative. I mean, both that one and the z's are both look relatively easy to do. So for my first step, I'm going to choose to take xy minus, 8x minus 4y plus the 7z equals 34. And I'm going to choose the second one, 5x plus 6y plus 3z equals -21. So what I see right now is that if I multiply, here I have a -4 and a 6. If I multiply to make them both 12s, I can cancel them out. So the first one here, I'm going to multiply by 3, and the second one, I'm going to multiply by 2. So let's rewrite them. This is going to give me 24x minus the 12y plus 21z equals 102. And then underneath it, it's 10x plus 12y plus 6z equals -42. I'm going to add those. So I'm going to get, on this black here, I'm going to get 34x plus 27z is equal to 60. So that's what I have so far. I'm going to do it again so I can get another one with just x and z's in it. So for the second set, I'm going to take the 8x again, this one, but I'm going to do this one now too. And so I'll put those arrows instead of minuses. So I'm going to do 8x minus 4y plus 7z. Let's make that most clear. Okay, equals 34. And underneath it, we have 3x plus 7y minus 8z equals -85. So one thing you can see here is you can use an equation over again, like I did with the 8x, as long as the second equation is a different one. So we will end up doing it with different things. So I'm going to choose here. I have to work on the y's. Now that I did the y's once, I have to do the y's again. So I'll multiply by 7 and 4 for these. And let's rewrite them here. So I'm getting 7 times 8 is 56x minus 28y plus 49z equals 238. Underneath it, 12x plus 28y minus 32z equals -340. And now we'll add them. And I'm going to get, in fact, I want to do the black here. So 56 and 12 is 68x plus 17z is equal to negative 102. That gives us our second of the XZ equations. So let's put those over on top of each other so we can analyze them and figure out which variable to get rid of next. Okay. So now let's figure out and think, what can I do here to multiply it or to get rid of one of these? So 34 and 68. Oh, well, now actually that one's easy because if I multiply this by 2, I'll get a 68 for that. And then the 27 and the 60 will also get multiplied by 2, but this one's key here because I only have changed one. And so that gives me 68x plus 54z equals 120. And underneath it, I'm not changing that one, so I'll just copy it over. And then I'm going to subtract them, because only by subtracting am I going to be able to do the 68, take away 68 to make that 0. And that means it'll be 54 minus 17. I really write that 7 better. Okay. And that gives me, if I add those up, oh, it's 54 take away 17. So it's 37z. And so it's going to be 120 plus 102 because of the double negatives. And when I divide both sides by 37, I get that z equals 6. So that worked pretty well to get one of these. Now I'm going to take one of these other two equations. I'll take the one that starts off with a smaller number, the 34, and let's figure out for that. I think this is actually our fourth thing here. Let's figure out the other thing. So I have 34x plus 27z is equal to 60, and z will be replaced by 6. Okay. So we get 34x plus 162 equals 60. 34x equals negative 102. X is equal to negative 3. Because 34 times negative 3 will give you negative 102. We now have two of these. Fifth step, we'll put both of these into one of the equations up top, and I'll just take the first one just because. No good because, actually. No reason not to. So I'm going to do that 8x minus 4. Well, actually, I did the other one black. I'll do a little 2 here. 8x minus 4y plus 7z equals 34. Make sure I have that right. Plus 7z equals 34. Yep, looks good. But now I'm going to rewrite it with the y replaced. Oops, no, it's the x that's replaced. The x is replaced by a negative 3. The z by 6. So I get negative 24 here, and 7 times 6 is 42. So that gives me an 18. So I have negative 4y plus 18 equals 34. Subtract 18 from both sides. Oh, we're going to get a pretty easy number to tell. When we divide by negative 4, we get y is equal to a negative 4, because negative 4 times negative 4 will give us 16. So now I have my 3 answers. So I put the x term first, then the y term, and then the z term. And it has to be in numerical order when we do coordinate points for a plane. Okay. Ooh. Uh-oh. Okay, one last try here. Okay, I think that's going to be good enough there. So let's take a look at an application problem, a word problem here. So 49,000 seats, that's total seats in the stadium. Tickets for the seats, upper level $25, middle level 30, bottom level 35. Actually, tickets for almost any event are a lot more expensive than that now, but this still makes for a good equation. So the number of seats in the middle and bottom levels together equals the number of seats in the upper. When all the seats are sold, the total revenue is 1.4 million and change. How many seats are in each level? So given that we are in series of systems of equations, I have a feeling we're going to make some equations here. Okay. The first one is relatively easy, and we have to decide something here. So we're going to decide variables. So I'm going to decide that I'm going to use X for the upper level seats. I'm going to use Y for the middle level seats, and I'm going to use Z for the bottom level seats. I could have used different variables or changed them around, which one's which. It doesn't matter as long as you pick 3 variables and that you make them consistent throughout the entire problem. So what I'm going to do here is say that X number of seats plus Y number of seats plus Z number of seats is equal to the total 49,000. And then next, I am going to look at the rest of the information to tell us how it helps me. Let's take a look at this line. The number of seats in the middle and bottom level together equals the number of seats in the upper. So the middle and bottom ones, which is Y plus Z, so the Y plus Z equals the number that are in the upper, the X. Well, we can rewrite that as if I move the X over, actually I move all the other things over. So I'm going to move that over this way, and I'm going to move that over this way, and then it'll be 0 there, which means that would be X minus Y, X minus Z, and we get 0 here. But let's keep it where we keep the X's first. X minus Y minus Z is equal to 0. And so we no longer need that. That was just work to get us to this. But the whole key to it was that X plus Z, number of seats in the middle. It's Y plus Z. So for Y plus Z equal the number of seats in the upper, X. That's where we got that. I think I'm going to erase all of that to make it a little neater than I did. Y plus Z is equal to X. But put that in parentheses and put it to here. So we know that we're not using this anymore, but it's what we use to get the second equation. Now, the next equation has to do with the money parts. So the 25 for X's, 30 for Y's, 35 for Z's. And so we're going to do 25 times X. That's the amount of money. If I sold 1 seat for the upper level, I'd have $25. If I sold 10 seats, I'd have $250. So it all depends on that number of seats. We don't know what they are yet, but we know close. Same thing with the Y's. Same thing with the Z's. But that equals the amount of money, which is 1,419,500. Now we have 3 equations. 1 equation, 2 equations, 3 equations. And what we can do now is to solve a problem. Well, we have something that sometimes happens with these types of things. Look at what happens with these two. I'm going to write them out. X plus Y plus Z equals 49,000. And X minus Y minus Z is equal to 0. But we now see if we add these, look at what happens here and look at what happens here. Now you see why it was so helpful to change the second equation around so we had all three variables on the left side. What we're left with is x plus x is 2x is equal to 49,000. So when we divide by 2, x is equal to 24,500. That gives us one of these. Okay, so we now know one thing, x, but we don't know everything else. So what I am going to do is I'm going to take this one, and I'm going to use one of the others to help with getting rid of one of the other variables. Okay, so let's see what I can do here. If I can get rid of either the y's or the z's, I would be able to put an x in to a problem and figure it out. So I'm going to work on I think I'll work on the z's. So first, so actually, let's sort of number what I did. The number one thing was the equation. Number two was this part down here. And then number three is going to be doing another system of equations. I think I'll do this one in blue to contrast with the last one. 25x plus 30y plus 35z equals 14, 19, 1, 419, 500. Now, I'm going to take one of these others. I think it's this one here. I'm going to multiply it by 35. So this is first equation times 35. And when I do that, I'm going to get 35x plus 35y. Oops, I didn't put the 5 there. Plus 35z equals, and if I multiply 49,000 times 35, I get 1715000. $1,715,000 for it. Okay, if I were to do this. So now what I'm going to do is either change one with all to negatives, or I'm going to subtract. So I'm going to do this one where I don't have to change anything else. So I'm going to get negative 10x, and I'm going to get, so 25 take away 35, 30 take away 35 gives us negative 5y, 35 take away 35, and that goes away, equals 14, 19, 500 divided by 17, 1500, gives us a negative 295,000. So negative 295,500 actually. Okay, so let's make that clear by making that a very clear 5. They all have negatives. So right now, well, actually, I can just solve for here, but it's easier if I don't have negatives. So I'm going to divide everything by a negative 1. And so I get 10x minus 5y is equal to 295,500. I already know what x is, so I can put that in here. 10 times 24,500 minus 5y equals 295,500. So this comes to 24500, one more zero, 245,000. And I'm going to subtract that from both sides. 245,000. So I get that negative 5y is equal to, let's do that. So, I forgot to change that when I did these negatives. That should be plus 5y. Okay, now it's correct. They're all pluses for this one. So I have a positive 5y is equal to 295 taken 2 over 5. You get 50,000 500. Divide by 5, and y is equal to 10,100. So now I have two of these. So I have x and y, and so we know, let's draw up here. If I do x plus y plus z is equal to 49,000, I now know that for x I can put in 24,500, 24,500. For y, it's 10,100 plus z is equal to 49,000. Hold on, I'm going to write this one more neatly and clearly to make sure that everyone can see it. Let's go here to do it. That's a y. Okay. So the x was 24,500 plus for the y, 10,100 plus z equals our 49,000 there. So this is 34,600. Subtract that from both sides, and we get that z is equal to 14,400. To write the answer, this is one that doesn't use a coordinate point because we're not graphing these. This being an application problem, we have to answer this question. How many seats are in each level? Put that in yellow there. So in each level, I'm going to say level upper. Now the upper were the x's, and then I'll say middle underneath it. And then I'll say bottom underneath that. The upper level ones, the amount was 24,500 seats. And the middle, 10,100 seats. And the bottom, 14,400 seats. So I'm answering the question with this. I can put levels there. And that would be the answer. So 24,500 for the upper level seats, and that many of them, and 10,100 for the middle, and 14,400 for the bottom. Okay, I'm gonna show that this is the answer. So this one wouldn't be in the coordinate point form because it doesn't make sense here. What makes sense is to state them in a sentence or to list them like this. At least I like a list like this. Okay, one more word problem to illustrate using a system of three equations. For this, I'm going to put in the values now. Mr. Garza invested 50,000, Ms. Garza invested 50,000 in three new accounts. She invested 3 times as much money in an account that paid 8% interest. She invested three times as much in that account than in an account that paid 10% interest. The third account earned 12% interest. If she earned a total of $5,160 in interest in a year, how much was it, or did she invest in each of the accounts? So let's figure out something. Like the last one thing starts off really easy. There's a total amount in 3 accounts. So let's call one of them X, Y, and one X, Y, one X, one of them Y, and one of them Z. I'll use X for that one. I'll use Y for this one. I'll use Z for this one. Just because it's in order. X, then Y, then Z. I could have done it with any others. That would be fine too. I'd still get the right answer. So my first equation is to say that the amount of money in X plus the amount of money in Y plus the amount of money in Z equals that total of 50,000 that she invested. That's an easy first one. Then we look at the amounts of money, the amount of interest. I'll say the amount of interest that was earned is 5,160. And that's because the amount of money in X, the interest rate on that is 0.08 plus then 0.1 interest times the amount of money in Y plus 0.12 Z. Z. Okay, make it clear that's a Z. Z's and 2's look too much alike if I'm not careful with my curves. So that gives us 2 of the 3. Now let's look at this part that will help us get a third one. She invested 3 times as much money in an account that paid 8% than an account that paid 10. So now we have to figure it out that one of those accounts has 3 times as much money as the other account. So is it going to be that it's 3 times X is equal to the amount that's in Y? Or is it that X is equal to 3 times the amount that's in Y? Which one is multiplied by 3? Okay, so let's think about it this way. If the amount that is in 8 is $1,000, how much is it that's going to be in the other one? So 3 times as much money in the account. So that means that if it's 1,000 in that, it would have been $333.33 in the other one. So because this account has more than the other. So we'd have to take the 10% interest one and multiply that one by 3 to get the amount that's in the 8% account. Or if I think of it then this way, if I have, say, 1,000 in this one, in the 10% interest account, then the other one, the 8%, is going to have 3,000. So that means whatever amount this is, the Y has to be multiplied by 3 in order to make it equal to the X. So we have X equals 3Y. So that means it's not this one. It's rather going to be this one. So I'll come over here and say that X equals 3Y, but it will be easier to work out in the problem, maybe. I don't know, would it be this way, or could we say it as X minus 3Y is equal to 0? I don't know. Let's keep that. One of them we'll use. We just don't know which one. We don't know how. So which one do we choose? Well, I think in this case, the fact that we have an equation, whether we use this one or this one, the fact is that we don't have a Z in it. So we want to eliminate the Z. And we can do that by making this one into 0.12 Z, so we can subtract them, or we could add them. In this case, I'll do it as subtracting on it. So I'm going to write out the 0.08 plus 0.1Y plus 0.12Z is equal to 5160. Okay. And I'm going to subtract from it. I'm going to multiply this one by 0.12, everything in it. Okay. And so I'm going to get 0.12 X plus 0.12Y plus 0.12 Z is equal to 6,000. Right, so I can subtract. In fact, I'm looking at this, and if I subtract right now, well, I can do that. 0.08 subtract 0.12 will give us a negative 0.04x. And then this one's like 10 take away 12 is with decimal. So it's negative 0.02y. These cancel out. Subtract one from the other one, they're the same. And here we're going to get a negative 840. Well, this is definitely a case where I want to multiply everything by -1, and let's make it positive. So what I get right now is 0.04x minus 0.02y is equal to 840. Now that means this is the better one to use, because I can now put In place of x, I can put 3y. 0.04 times 3y minus 0.02y equals 840. So just calculating things out, 0.12y minus 0.02y. And now I'll combine these two like terms. So it's 0.12. Oops, I forgot something. Once again, this is positive. I did that in the last problem. So I have to be really careful that double negatives are positives on that one. Did it for the first one, forgot again the second. So that makes a difference here because instead of 10, we're going to get 14 or 0.14 y. Make my y's again careful here. Is equal to 840. When we divide by 0.14 now, 4, okay, we're going to get, when you do 840 divided by 0.14, you get that y is equal to 6,000. Ooh, a nice simple number with that. So if y is equal to 6,000, let's immediately go to this thing here. I'll write it up here. X equals 3y, so x equals 3 times 6,000. X equals 18,000. Yay. And now for the z, we need to figure out, we have to get it all to make 50,000. So we have 18,000 plus 6,000 plus z is equal to 50,000. So this comes to 24,000. And when we subtract it from both sides, we get that z is 26,000. So our answer in this is going to be that 8% account has 18,000 in it. The 10% account and that's what I need to show with these dots here, has 6,000 in it. And the 12% account, which because it's going to get the most interest, makes the sense to have the most money in it, has $26,000 in it. That accounts for them all totaling 50,000, and that the second one is 1/3 of the first one. The first one is 3 times the second one. Okay. So I'm going to yellow that one in. And then let's review what we did here. First, we get those numbers. Coming back up here, we had to make these equations, this one, and this one, which could have been changed to this, but we didn't need it that way. If it had been useful, that would have been a good way to do it. Okay. Then, so that was sort of the first thing to do, was to make the equations. Second thing to do was to solve it down to get to one of the variables. And the third thing to do was to use that to get the other variables. And then finally to specifically answer the question with them. So this one, the second step, required that we subtract 2. We had to change one of them. And I guess it was actually that one. And then we had to substitute. So I guess I'd call this like 2a in that one, or this would be 2a and this would be 2b. Okay, so 2 parts to that one. But it's just solving equations. You just have to change some of the equations. At the beginning, you have to make the equations based on the information here. That's what we did with this other problem as well, the seats in the sports stadium. Both of them illustrate ways of making the equations, especially for sort of the weird one here that requires that one of them, one variable sort of based on the other one, and we don't need both of them. We had that up here. when we made these, it was that, in this case, it was that two of them equaled the third one, and that allowed us to get this first equation. We could then get the second one, and the third one was based on the amount of money. Once you get the equations, it becomes just like these original problems, except that these are actually a little harder because you end up having, in these, the extra equations give you something like here with no coefficients in these, it's easy to multiply them to get rid of a variable in one of the others. All right, so these were good examples for you to hopefully understand how to do this with some of the little variations that you can see in it. And I hope it was very helpful. Thank you for watching and listening.